Hey, what's up? Welcome back. Patrick here from All Things Mathematics, and moving on to the next example dealing with linear algebra. Here we have to find the value or the values of m. Notice we have a bunch of m's here in this system. That's going to give this system a two-parameter solution set. Okay, so lots going on here. A two-parameter solution set, what does that mean? It means that two of the variables have to be free variables. Okay, and if we look at this is already reduced in a pretty good way. So notice that on the left side of the equation, right, this line here represents like an equals, we're dealing with four variables because we got four columns, right? So we have x1, x2, x3, and then all of these here, including these expressions, this quadratic, this linear, this represents x4, like that. And then basically that left side is equaling this right side, right? These here are going to be constants on the right side without any variables. So they want a two-parameter solution set, meaning that two of these four variables have to end up being free variables. Well, notice that we already have pivot points for x1 right here, so we know that x1 can't be a free variable. And we also have a pivot point here for x3, so we know x3 can't be a free variable. And so notice that basically what's remaining is x2 and x4, right? So notice that x2, it has no pivot point right here where we're going to be able to isolate for it. So we know that x2 already is going to be a free variable. We could call it m. And since we just mentioned x1 and x3 can't be free variables, that means we need to get x4 to somehow be a free variable where we can make it equal to n. Now, if you think about it, the only way that we can get x4 to be a free variable here is if this term is going to equal 0. Right? Because if it's going to be some kind of number other than 0, notice that that's going to serve as a pivot point, and then x4 is no longer going to be a free variable, right? Then x4 is going to have to actually equal some kind of value, okay? If we get something other than 0 here, because then you could get like 3x4 is equal to some kind of value here, let's say 5, and then x4 x subscript 4 is going to equal 5 over 3. Now, if you think about it, the only way that x4 is going to be able to be a free variable is if this term right here is going to equal 0, right? Because then x4 is not going to have some kind of pivot point. Because if this term is something other than 0, then what's going to end up happening is you're going to have like a constant, right? Some kind of constant, x4 is equal to some kind of other constant over here. Let's say it's going to be like 5. Okay, it could be something else, but let's just pretend that it's going to be 5. So then notice that you're going to get an actual value for x4. It'll be like 5 over whatever that constant here is going to be other than 0. And then x4 won't be a free variable then, right? And then it's not going to be a two-parameter solution set. It would only be a one-parameter solution set where only x2 would be the free variable. We need x4 to be a free variable. And the only way that that could happen is if this term right here, this m squared plus m minus 6 is going to equal to 0. Okay, again, because if it's some kind of other number other than 0, you're going to have some kind of constant. Again, let's say it's like 2. You'll have 2x4 is equal to some kind of other constant. x4 is going to equal basically a constant. It's not going to be a free variable. Okay, so that term has to equal 0. Now, here's the thing though. This term also has to equal 0. Now, why is that? If you remember, and I've gone through this in previous videos, there's basically two types of solutions, right? We can have an inconsistent solution, and we can have a consistent solution. And then consistent, we could have a dependent solution or an independent solution, right? So if it's an independent, consistent solution, that means there's only one solution to the system, which is not what we want. Because we want a two-parameter solution set, it means that there's going to be an infinite amount of solutions. So it's going to be a consistent and dependent solution. And then finally, an inconsistent solution means that there are no solutions. And this is what I want to focus on here, is because when do we get an inconsistent solution in a matrix? Well, it's whenever we have like 0 on the left side of the equation is equal to some kind of other constant other than 0. Okay, so notice that here, this m minus 2 also has to equal 0. Okay, and that's going to happen at an m value of 2. Notice that this here factors into m plus 3 and m minus 2. And so for this quadratic to be 0, it could happen at two different values, -3 or +2. However, we would only use the +2 because we also need this to be 0. And so that's actually the answer to this question, an m value of 2. However, I do want to dig into the details a little bit to explain why it has to be 2 and why can't it be, for example, -3. Because a value of -3, an m value of -3 would also make this 0. But what's the problem? It's not going to make this 0. If we plug in -3, we'll have 0 here, but we're going to end up having -5 over here, which would make this entire system then be inconsistent, meaning that it won't have any solutions, right? And so then it won't have a two-parameter solution set anymore because it doesn't even have a chance to be consistent, right? It doesn't have a chance. We want it to have an infinite amount of solutions, consistent and dependent. Well, it can't even be consistent because this here, right, when you have this 0x equals some kind of constant other than 0, then you know the whole system is inconsistent. It wouldn't have any solutions, right? So this m value of -3 is not going to work. Even though it's going to make this 0, which is what we want, right? We don't want x4 to have any pivot. It's not going to make this 0, right? An m value of -3 would make the entire system be inconsistent. Okay, so that was one of the tricks there, right? So it can't be this -3. It has to be this, this m value of 2. Now, if we actually do plug in, let's see what it's actually going to be if we do plug in this m value of 2. Let's maybe do it in a different color for all of these. Notice here, you'll have 2 minus 4, which is -2, and then over here, 2 squared, which is 4 minus 16, gives us -12. Here we're going to have 0. Here we're going to have 0. And so the new simplified matrix, if we're plugging in this m value of 2, is going to be here, right? So I wanted to write a nice one here so we could see what the actual solution is going to be. Now, again, this is not, that's not what they're asking for. They were just asking for the values of m that are going to make this a two-parameter solution set. So m is 2 is the answer, but just in case you were wondering how the solution is going to look like, thought I would show it. So again, x2, no pivot, x4, no pivot, so those are the free variables. And then let's make an equation here with the first row. So we'll have x1 minus 5x2, and actually x2 is equal to m. So let's just plug in the m right away. So this is going to be minus 5m plus x3, that's not a free variable, plus 2, x4 is equal to n. Right, and that's going to equal 3 like that. And then over here with the second row, we could say x3 minus 2, x4, which is n, is equal to -12, right? So notice that x3 is equal to -12 plus 2n, like that. So that's the solution for x3. And then over here, if we isolate for x1, we'll have x1 is equal to 3 plus 5m minus x3 minus 2n, right? If we bring everything over instead of the x1, keeping the x1 on the left side. And then what's happening is for this x3, we could plug in this expression -12 plus 2n. So what would happen? We would have x1 equals 3 plus 5m minus, in brackets, negative 12 plus 2n minus 2n, like that. And so notice that x1 is basically going to end up being what? 3 plus 12, which is 15, plus 5m, and then minus 2n minus 2n minus 4n, like that. So that's what x1 is going to be, right? So notice two parameters, right? M and n are affecting the entire system for the solution, right? So the x2, x4, they are the free variables, m and n, and then x1 is equal to 15 plus 5m minus 4n, whatever you pick for them, and then x3 is equal to negative 12 plus 2n, right? That's the two parameter solution set for this matrix, and that can only happen when m is equal to 2. And that's a wrap for the video. Hopefully you enjoyed that. If you want to see more videos like this, please go to my website, allthingsmathematics.com. Over there, all of the videos are organized by chapter, by section. If you feel like you need tutoring at any point, you could also hit me up. My contact details are on the website. Enjoy your day, and I'll see you in the next one. Peace out.